the way we sketch graphs depends on the numbers that are a part of the equation. So for this equation here, y equals 1x plus 1, which is the same as y equals x plus 1, it's the same as y equals x, except that every x value has 1 added onto it. Here is the equation of y equals x. Here is the equation of y equals x plus 1. Y equals x plus 1 is 1 higher for every point of the graph. So at 1, 2, 2, 3, etc. Every point on the grey graph is 1 below the blue graph, because the plus 1 adds 1 onto every value of x. This is called a translation in the y direction. From this graph you can see that if I do y equals x plus 2, every point will be 2 higher than my original y equals x. Every point is 2 higher. Here is the same thing for a cubic graph. Y equals x cubed is the pink graph. Y equals x cubed plus 1 is the blue graph. Every point on the blue graph is 1 higher than the pink graph. It looks like they're coming together here, but follow it vertically. There's my x value for the pink graph, there's my y value for that's still a distance of 1, which is easy to see here, but perhaps not so easy to see here. But every point is 1 higher, because every time we work out an x cubed, we add 1 onto it. If we subtract 1 from our x cubed, every point is 1 lower for the y value. So here is y equals x cubed, here is y equals x cubed minus 1. Every point is 1 below. Hopefully you can see a common theme. Things added onto the end here, like plus 1, minus 1, plus 2, move the graph up and down without changing its shape by adding or subtracting to each answer. Here is another one. This is the sine graph. This is the shape of y equals sine x. And the blue one is y equals sine x plus 1. So sine x gives us the pink shape, but because we're adding 1 onto every particular answer, the blue graph is 1 higher everywhere. And you could probably see this fairly easily, that every point on the blue graph is 1 more than every point on the pink graph. So when the graph moves up and down like that, or goes up in this case, that's called a translation. Every point is 1 higher, or a certain number higher. Translations don't change the shape. What happens is every point on the graph is moved the same amount, in this case up by 1. So in the previous changes in the y direction, we were adding a number to the graph, and the whole graph moved. Now we're going to multiply by a number. Here is y equals x, 2x, and y equals 3x. This one is y equals x, this one is y equals 2x, and this is y equals 3x. The number that's multiplied makes it look like the graph is rotating around like this. But what really is happening is the answer that we get for x is being multiplied by 3. It's stretching the numbers this way. It's making them 2 times bigger for this graph and 3 times bigger for this graph. So if I start off with x equals 1, the first graph gives me an answer of 1. When I multiply that by 2, it's stretched up here to 2. When I multiply it by 3, it's stretched from here up to here. It has the effect of looking like it's rotating like that, but every point is being stretched. We call that dilation. And this number here in front of the linear graph, which we also call the gradient, stretches the points in the y direction. Down here it comes down in the negative y direction, up here in the positive y direction, but they're being stretched, not rotated, even though it looks like that's what's happening. It's probably easy to see what I was talking about with a sine graph. Here is the sine graph for y equals sine x. Here is the graph for 2 times sine x. Every point is doubled. Now if you double 0, it stays 0. If you double 1, it goes to 2. So you can see that the shape has actually been changed. The graph has been stretched by pulling down this way and pushing up that way, or pulling up that way by doubling all the values for sine x. They're all twice as far from the x-axis. This one's twice as far from the x-axis. This one's twice as far from the x-axis. So the 2 types of changes in the y direction are translation and dilation.